Tonight I want to do 4 stories, I think 4 different missions that are, 3 of which are in progress, 1 of which is about to start. And so the first of these, I've been promising all of our regulars for about 6 months to do an update on the Dawn mission. Dawn is a spacecraft that has orbited 2 of the largest asteroids in the solar system. It got to the asteroid Vesta several years ago, orbited for well over a year, totally mapped it, and then using its ion propulsion, it was able to leave orbit and move on to the next target, which is the largest asteroid, and actually it's now considered to be a dwarf planet in the same category as Pluto, and that is Ceres. And so this is what it's been doing at Ceres. This is a view looking sort of down on the North Pole. And when it first arrived about almost 18 months ago, it entered this very high orbit. And then it took a sort of mapped Ceres from there, and then it dropped down to about a third of that distance, and completely mapped Ceres from there, dropped down to about a third of that distance to this is called the survey orbit, the high altitude mapping orbit. So it mapped Ceres from there, and then it settled into the low altitude mapping orbit, which is where it is today. And so I want to go through some of the recent findings and give you an idea of what Dawn has been up to. So the first thing is, at this point, we actually have a global map of Ceres. And this is, it's jagged at the bottom here because that part of the dwarf planet is in darkness. It's tilted on its axis. So just like the Earth in winter, that's the winter hemisphere for Ceres. It's not illuminated at this point. So if dawn lasts long enough, that will slowly be filled in. So I think next we have a short video.
Dwarf planet, the Dawn's been orbiting for more than a year now, providing us with fascinating
I'm going to start that over so we actually get the audio. It helps if I have it turned on.
This is Ceres, the dwarf planet the Dawn's been orbiting for more than a year now, providing us with fascinating views of an alien world. During its exploration, Dawn has moved closer and closer, allowing us to get a broad overview and then see exquisite detail. This is Ahuna Mons, the highest mountain on Ceres. Towering in an otherwise unremarkable area, it seems very odd that it rises so sharply, and geologists still don't know why. On its steepest side, it soars 3 miles, higher than any peak in the continental United States. Couture Crater, one of the brightest regions on Ceres. It's about 21 miles across. Its well-defined shape indicates it's relatively young, the impact that formed it having occurred in recent geological times. You can see a substantial amount of bright material, which the latest analyses indicate may be a kind of salt. This is Couture Crater, which shows more of this intriguing bright material inside and out, as well as a peculiar shape. At 6 miles in diameter, this is the second brightest feature on Ceres. You can see next to it an intriguing linear feature called a slump, where a mass of material has dropped below the surface. This is Couture Crater, about 105 miles in diameter, although not the largest on Ceres. Although many craters have a mountain in the center, Couture has a prominent double peak, surrounded by rough terrain and linear parallel grooves. The Couture Crater, 57 miles across and 2 miles deep. As dawn closed in, what initially looked like one spot became 2 and eventually a multitude of features. This reflective material makes it the brightest region on Ceres. The crater also appears to be among the youngest on Ceres. Dawn mission scientists estimate its age to be about 80 million years, which is quite young in geological time. Dawn is now orbiting only 240 miles above Ceres, which is closer than the space station is to Earth, and it will continue to return spectacular views.
Okay, so that's the overview, and what I want to do is show you some of the high-resolution images that went into this movie. So first, this is a global map that is showing the data from a neutron spectrometer. What it's doing is measuring reflected neutrons that come in from the X-rays and things like that from the sun, and bounce back and are detected at the spacecraft. And so what you see here, this is the North Pole of Ceres, and blue is a low abundance of neutrons. This is a sort of a medium abundance and then a higher abundance. And you might ask, so what? But neutrons, the interpretation of this type of instrument is where you have a lot of hydrogen in the surface. It absorbs the neutrons, so you get fewer of them reflecting. And so this would indicate a region that is high relative abundance of hydrogen, gets less as you move away from the polar region. And typically, what that would be related to is the abundance of water. And so on the moon and on Mars, we've used instruments like this to map the occurrence of ice in the near surface, the meter or so below the surface. And so this is sort of what we would expect for Ceres. We know that just based on the density of Ceres, it's not as dense as rock would be. And the assumption is that it's, or the conclusion is, that it's actually got a fair amount of water mixed in it, water ice. And so that's saying that there's more of that in the polar region than there is near the equator. And that's sort of consistent with what you'd expect. It's a little bit colder there, so anytime you have an impact, it sprays material off the surface. You sublimate whatever ice is exposed to the vacuum, it just evaporates. But if you have a cold area on the planet, the water molecules sort of bounce along the surface unless they're lost to space, and ultimately they deposit where it's coldest. And so you get an enhanced abundance of water in that area. So that's a preliminary result, but it's very promising that they're actually seeing an ice map here. Okay, and this was one of these craters that was mentioned in the video. And let's just zoom in a little bit. So this is overlaid, the color overlay is from a visible and infrared mapping spectrometer. And so it sees in wavelengths that are longer than what your eye can see. And the infrared wavelengths can be used to detect differences in the mineralogy, so the surface composition. And without much more information than that, what we can say is all this blue stuff was splashed out of this crater when the impact happened. And the basic conclusion here is that we've excavated material from under the surface and sprayed it out in the surrounding areas. They're still doing the analysis about what the composition of that material is, but what we can say at this point is this is different than what's out there. And now that gives us a good target to actually spend the effort and considerable amount of time to do the detailed analysis of those spectra. This is a close-up of one of these craters where there's a slump feature. So this is the wall of the crater. If you're having trouble seeing this as an innie, this is lower than this. So this is the surrounding area. This is a hole in the ground. And this was the original crater wall. And what you're seeing here is a big landslide where this wall slumped away from its original form. And so again, that says that the surface evolves with time. If it was just pure rock, you might expect it to, when you get an impact and you get a big crater, once it happens, it's just going to sit there. And this could be consistent with the idea of that you've got a fair amount of ice mixed in the subsurface. When you've exposed that to vacuum, the ice sublimates, and when it goes away, that removes some of the strength of the cliff face, and eventually it gets weak enough that it just slumps away. We see this a lot on Mars, so that's a process that is fairly well understood, and it's interesting to see it on a body the size of Ceres. This is a perspective view of that mountain they were talking about. So this is about 5 kilometers high, and that's still a puzzle. Why is there a mountain? Usually, let me back up here. You see mountains in the middle of craters. That's sort of, you've probably seen videos of when a water drop is going into a puddle. It makes sort of a crater, but then you get a rebound in the middle, sort of a drop that goes upward. The same thing happens even if it's solid rock with all the energy that's expended in the impact. And so you see central peaks, central mountains a lot. This is not one of those. And so the question is, how was it formed? And on the Earth, or on most planets that we know of, that implies there's some sort of forces deforming the crust. And the geologists on the mission still don't understand this, but it's a very interesting feature. Okay, and this is for the regulars in the audience. This is something we've been talking about for almost a year. So this is Couture Crater. As it said in the video, this is believed to be one of the youngest features on Ceres, less than 80 million years. From a distance, when all we were seeing was, this crater was just a few pixels across, it was extremely bright. And as we got closer and closer, the bright spots started becoming more and more bright spots. And so this was from that survey orbit back over a year ago, and you could see at that point we knew that there was 7 or 8 spots. And then 3 months later, when it dropped to the high altitude mapping orbit, you started to see a lot more detail. These aren't just spots, there's actually structure to those spots. And this is the view, the latest view from the low altitude mapping orbit. And this sort of looks like what we saw before, but if I actually zoom in to the full resolution, you can see there's a lot going on here. There seems to be a series of fractures in the area where the spots are. In this largest one, they actually have topographic maps. There's a dome in the center, so it's uplifted, and there's cracks that are sort of radial to that, moving away from the center. This is an overlay from that visible and infrared mapping spectrometer. And so what that says, there's sort of a pinkish area here. And all the whitish stuff is probably the same composition. The pinkish stuff, something different. And so the initial interpretation when they saw this was, okay, this looks like it's something that's coming up from subsurface. So I hesitate to use the word erupting, but it's at least leaking out from the interior. And so they were waiting to do the analysis of the spectra, whether this was ice, is it some sort of a salt, is it a particular mineral. And just today, just in time for this talk, they released this result. It's published in the journal Nature. And so here's our spot area. This is a perspective sort of looking in this direction. Fortunately, it's rotated about 90 degrees. But these color stripes, oops, sorry. All right. These colored stripes are where the visible and infrared mapping spectrometer has crossed. And you see there's sort of a blue rim around this feature in particular. But what you really want to notice is this red deposit in the center. And they've done the analysis of this now. What the red stuff is sodium carbonate. So it's a type of salt. It's certainly known on the Earth. What's really interesting about it is on the Earth, it primarily forms in a hydrothermal area. So it's an area where you've got hot water bubbling up from the interior. And then when it reaches the surface, the water evaporates and leaves whatever's dissolved behind. And so that's, there's still argument, is that when this impact happened, there was so much energy that this surface was molten for a while and it slowly cooled off. And so that provided the heat necessary for the hydrothermal activity. Does it imply that at one point Ceres had a hot interior? And so you had pockets of liquid, perhaps, under the surface of water that, just like a volcano, would erupt in weak spots. And I think the jury is still out on those two camps of thought. But at this point, the interesting thing is, for a long while, it was assumed that this bright stuff was ice that had been either erupted or excavated from subsurface, and that's not true. It's a particular composition, and it's a composition that implies an interesting history for Ceres. It's a lot more complicated than most of the simple models would have you believe. So where we're at now is Dawn is doing its thing. It's continuing to map the planet, and you can sort of say, well, it's already mapped it completely, so what are we going to learn by continuing to map it? But what they've been doing is, imagine I'm the camera on the spacecraft. So for when it first arrived in that low altitude mapping orbit, it was pointed ahead of the spacecraft. And so it got a view in that direction. Once it had completely mapped the planet that way, it turned and the spacecraft is moving this way, and it sort of looked off to one side. Now it's looking off to the other side. Then they'll do something like this, and turn around and do it behind them. And what that allows is very, very accurate three-dimensional views of the surface. And you can turn that into topographic maps. And so we'll learn a lot more about things like that mountain, learn about those slumps. You'll know exactly, within probably half a meter or less of what the elevation is everywhere on Ceres. And that's a really important thing to do. The current thinking is, with the amount of fuel that they have on board, they expect they'll be good at least until the end of this year, possibly into the middle of next year. Ceres uses xenon as its propulsion. It's an electric rocket engine. It ionizes the xenon and spits it out the nozzle here. And it's a very low thrust system, but it can operate for a long, long time. It's very efficient. And so they know how much xenon they're burning right now. It's a fairly small, controlled rate. About every 3 weeks or so, they need to adjust the orbit. Ceres is sort of lumpy, so it's hard to stay in a circular orbit. You have to keep tweaking it. And that's what they're doing. So stay tuned. I'm sure we'll have more updates on future missions. But at least I finally got to fulfill my promise that I'd tell you what those white spots are made of. Not a second too soon did that come out today. So.